forgot. I didn't really care. Okay.
Don't we have to?
So this one, we talked about how if it's in vertex form, it's a lot easier to graph because you can apply your transformations.
I remember Jerome's name was Pete.
Where were you at? We go to.
I'm trying to teach class. If it's in standard form though, can you look at that and tell what the transformation is? X squared plus 2x minus 5? No. So that one we did yesterday by plotting points, but we figured out that's not really a good option. So we need a better way to get there. So what we're going to do is rewrite this in vertex form. Remember that vertex form we wrote down yesterday? F of x equals a times x minus h squared plus k. So let's do that. What we're going to do here is go back and we're going to be completing the square. Do you remember talking about that back when we were factoring, working with quadratics? Okay, so back then we were always able to just move the constant to the other side. The other side of my equation is an f of x. I don't really want to put anything over with the f of x. So instead, what I'm just going to do is add parentheses. So my x squared and my 2x are going to go in my parentheses. I'm going to leave a little space. And this minus 5 gets stuck on the outside. Okay, so now we need to complete the square. So we have to figure out what number to add here to make this a perfect square. So if we want to make it a perfect square, what do? Middle term divided by 2 and then squared. So 2 divided by 2 is 1. 1 squared is 1. So I'm going to add 1. Now, if I add 1 here, what do I have to put out here so I didn't change my problem? Except since it's on the same side, if I'm going to add 1, the opposite would be subtracting 1. Since I'm keeping them on the same side, I'm going to add 1 inside the parenthesis, subtract 1 outside the parenthesis. So this has created a perfect square. Okay, so this should factor into something squared. So x squared goes down to x. Middle sign was positive, so plus the square root of 1 is 1. Minus 5 minus 1 will give me a minus 6. Is this vertex form?
Yep.
Yeah. We could look at this and just find the vertex. What's my vertex going to be? -1, -6, because the formula has x minus that h value, so a plus would be like minus -1. Okay, so a couple options for graphing. One option is just using your transformations and saying, okay, I'm going to take my x squared, I'm going to go left 1 and down 6. The other option, and this is more how you did it back in Algebra 2, is you know the vertex. So you can plot your vertex, -1, -6, and then that just gives us 1 point. What else would you have to do here? 1 point isn't enough to draw the graph. You'd have to put in some additional points, wouldn't you? So that's at -1. Let's say if I put a 0 in, I get 1 minus 6, which is -5, so 0, -5. I could put in a 1, 1 plus 1 is 2, squared is 4, minus 6, -2. If you remember back your Algebra 2 days, the axis of symmetry goes right through the middle here. So if you have one side of the parabola, that's really all you need. Why? Right, you can just reflect it over. So this point is 1 away from my axis, it goes 1 in the other direction. This one is 2 away, it goes 2 the other direction. So I'm just trying to give you guys lots of options for graphing it. We've talked about just straight picking points from the original. Yesterday we really focused on the transformations, which you could do here as well. Or you could work from the vertex and just pick additional points and use your axis of symmetry to get the other side. Any of these are options for drawing your graphs. Questions about that? Let's go ahead and give the domain a range. What is my domain? To positive infinity. My range? Bracket -6 to infinity. Let's look at this one. You guys think you can complete the square by yourself? Why don't you try it? I'll give you a couple minutes to try, and then before you graph, we'll make sure you have the right thing. So what's our first step?
Complete square. Number is +7.
Okay.
-6, -2.
So -6 divided by 2 is -3. -3 squared is
9.
Positive
You gotta
9.
subtract 9 from 7.
right. If you add 9 here, you subtract it out here. So x squared minus 6x plus 9. What does that factor into? X minus 3 squared. 7 minus 9. Okay, so from this, what is our vertex? 3, -2. Okay, you could graph this then by starting at 3, -2 and picking additional points.
How do you get the vertex?
The formula is x minus h a times x minus h squared plus k. So the 3 is my x, we're adding a -2. Okay. And then you could pick additional points. You could do transformations if you're more comfortable with that. We focused a lot on transformations this year. Just a review from yesterday, if you started with your parent function, you would move each point right 3, down 2. So we see we get the same graph. Either way. If I ask you to draw the axis of symmetry, where's that? At x equals 3, right? The vertical line going through there. Okay. What's the domain?
-30
The range?
-2. Little bracket. To infinity.
Are those okay? Alright, do we need to do some more completing the square examples?
No.
So the benefit of completing the square is if you do that, then it's in a simple format to do your transformations. Like once I got this, I could easily see I had to move right 3 and down 2. Now there's another way to go about graphing these. So I'm giving you lots of different tools here. And this one is to take something in standard form and you actually don't have to complete the square. We'll do that one in a second. So, what you have to do first is be able to find the vertex. To find the vertex, there is a nice handy formula. Melissa, you remembered this the other day. What was it?
The opposite of B of 2.
Right. If you look in your book, or if you remember from Algebra 2, it looks kind of ugly. Your x is the opposite of b over 2a. Then all this means is once you have x, you plug it in to get your y. So the really important thing you need to know here is the x value of the vertex is the opposite of b over 2a. That's when it's written in standard form. Then once you have x, you can plug it in to get y. So nice handy formula to find the vertex if it's not written in vertex form and you need that. Opposite of b over 2a. Okay, then we can use, that is actually the equation for the axis of symmetry. Because the axis of symmetry is a vertical line, we know it's always x equals, so that would be your axis of symmetry. X equals the opposite of b over 2a. So let's do this problem. Without drawing a graph, we are going to find the vertex and axis of symmetry. So we could first complete the square here. The thing is, completing the square if your coefficient isn't 1 is a little more work, and I'm going to show you an example of that in a minute. The other option, if you don't want to go through completing the square, is to use that formula. The x value of the vertex is the opposite of b over 2a. What is my b value? 6 over 2 times what's my a?
Negative.
So you get negative 6 over negative 6, which is 1. So in my vertex, 1 is the first value. How do I get the y from that?
Flip that in for x.
Okay, so f of 1, negative 3 times 1 squared would be negative 3. 6 times 1 is 6, so we're up to 6 plus 1. So my vertex is 1, 4. So what is the axis of symmetry?
X
X equals 1. Has to be an equation because it is a line. It's vertical, so it's x equals 1. The other question I asked you is, does this parabola open up or open down? How do you tell?
If it's negative out,
It's a negative out front, so it opens
down.
down. If you remember your transformations, that negative in front actually flips your parabola. So if it opens down, do we have a maximum or a minimum? A maximum, and that maximum actually happens at our vertex. Okay, I'm going to show you another example. This one isn't on your handout. We're going to come back and do B and C in a second. But I want to show you the benefit of this. If I asked you to complete the square for this problem, so you might just need to add this in. There's a back that's empty, so you can put it back there. Completing the square requires the coefficient on x to be a 1. So you would start out grouping these like normal, but because that's not a 1, you would actually have to factor out a 2. That would give me x squared plus 1/2 x. This minus 6. So it's a little bit uglier. We have a fraction in here now. So to find what we're adding, you take your middle term, divided by 2, and square it. So 1/2 divided by 2 is 1/4. 1/4 squared. 1/16. So you add a 1/16 here. Now here's where you have to be really careful. I put a 1/16 in my parenthesis, but that's not really all I added into my problem. Because there's a 2 out here that would get distributed to that, correct? What's 2 times 1/16? 1/8. So you actually would subtract 1/8 out there. Because you have a coefficient, you have to multiply it before you figure out what you subtract off. So we get f of x equals 2. Okay, x squared goes to x. This was a plus. Square root of 1/16. Square root of 1 is 1. Square root of 16 is 4. Minus 49/8. Is this one going to be a nice, pretty vertex? No, not at all. You know your equation, your a, x minus h squared plus k. So my h is going to be my k is going to be -49/8. And so then you would have to graph this if you were using transformations. You know, you would move left, down, you would stretch it, and get your graph from there. Other option for graphing would be to start by first graphing the vertex as best you can, and then picking additional points to get the full graph. Either way, it's not real pretty, is it? You know, if we put in a 0, we get out to -6. If you put in a 1, you get -3, but you have to watch when you flip these things. We're measuring from here, so it might even be easier just to put in some others, like -1. Give me -5, -2, -4. So definitely not a pretty graph, but you can get it. But this is an example of when completing the square is really kind of annoying, right? It's not going to give me pretty numbers. I had to factor out that extra 2. Then I had to really think about what I was adding and subtracting, and it just made the problem get really ugly. And plus, once I did the graph, the transformations weren't easy because I was trying to stretch it and move it to weird numbers. So completing the square really wasn't pretty. That's why the vertex formula is so nice, because it allows you to quickly find that vertex whether it's nice or not. You can easily find it. You can easily plug in some additional points to the equation and figure out where to draw those, so it doesn't create a lot of extra work for you. So if I gave you a problem like that and just told you to graph it, personally I wouldn't complete the square. I'd probably find the vertex and pick some points. Okay, I want you guys to try B and C. Find the vertex, find the axis of symmetry, decide if you open up or down. So first one, find the vertex. You do the opposite of B over 2A. So that would be the opposite of -8 over 2 times 4. So 8 over 8 is 1. So that's the x value of the vertex. Plug it in to get your y. And you get 3. So then the axis of symmetry, x equals 1. Open up or down? Right, so this would be a minimum point. Right? If I told you to graph it from there, all you would have to do is plot that vertex. You know, you could say the axis is going to cut it in half, so then just pick a point. You know, put in a 0, you get 7. Then you know that point reflects over. And you can easily draw your graph. Okay, C. So x equals opposite of B over 2A. So opposite of -4 over 2 times -8. 4 over -16, which is -1/4. This one would have definitely been ugly to work with completing the square. To get the y value, plug that in. So -1/4 squared would be 1/16 times -8 is -1/2. Plus 1 minus 10. And so what do you get? Yeah, -9.5, I think. Or you could have -18 or -19 over 2. Either way. So what is our axis? X equals -1/4. Open up or down? How's it opening? Down. Alright, any questions about these? The last thing I want to look at today, we're just going to briefly talk about the discriminant. you've seen this before. The discriminant is used to find the number of x-intercepts, or you might call them solutions, or roots, or zeros to a quadratic equation. When I say the discriminant, what am I talking about?
The square root.
Right. If you think about the quadratic formula,
It's just a square root.
the discriminant is that part under the square root, that b squared minus 4ac. So let's just think about that in terms of the quadratic formula. So that gives you your solutions. If you plug that in and you get a positive number under your square root, how many solutions do you have?
2.
If that was like a 4, then you would have something plus 2, something minus 2. You get 2 real solutions, right? So if the discriminant is positive, two real solutions. What if it's 0? Okay. Something plus 0, and something minus 0, don't those equal the same thing? So in terms of our solutions, we just get the same number out twice. So we're getting one real solution. What if that's a negative under the square root? Right, anytime you get a negative under square root, then you get an I. So you have something plus that imaginary number, something minus that imaginary number. So that is 2 imaginary solutions. Any questions about that? That's actually our stopping point for today. I'm only going to give you a few problems, so we'll kind of see if we get done before the end of the hour. We might grade everything. If not, then we'll do it Monday.
$88.8.
Okay, so on page 313, you can add this to yesterday's. We're going to do 20 through 22.